Imagine a simple substance that holds together everything from your smartphone to an entire skyscraper. Humans have been mastering this incredibly powerful technology for over 200,000 years, long before metalworking or the wheel. This ancient innovation, often overlooked, performs a molecular dance that defies gravity and incredible forces. It's not just sticky. It's a testament to fundamental physics binding our world in countless, often invisible ways. This remarkable substance is, of course, glue, an adhesive that creates strong, lasting bonds between surfaces. Adhesives are distinct from fasteners like screws or nails because they rely on surface chemistry, not mechanical force. From the sticky sap used by Neanderthals to modern superpolymers, glue represents continuous human ingenuity. Understanding glue reveals a fascinating interplay between material science, engineering, and everyday utility. Without these versatile bonding agents, much of our engineered world would simply crumble into disconnected pieces. Early glues came from natural sources like animal hides, tree resins, or even blood, demonstrating resourcefulness. These ancient concoctions allowed our ancestors to craft tools, build shelters, and develop complex societies. Modern adhesives, however, are sophisticated chemical formulations engineered for highly specific, demanding applications. They offer incredible strength, flexibility, and resistance to environmental factors like heat or moisture. You might not think about it often, but glue is a silent, essential hero in countless manufactured products. So how does something so seemingly simple achieve such extraordinary, fundamental connections on a microscopic level? The magic of glue primarily happens through two key principles: adhesion and cohesion working in tandem. Adhesion refers to the attractive forces between the glue and the surfaces it's bonding, like tiny molecular magnets. Cohesion describes the internal strength of the glue itself, ensuring it doesn't just tear apart from within. When you apply liquid glue, it spreads over the surfaces, ideally filling every microscopic crevice and pore. This process, called wetting, is crucial because it maximizes the contact area for the adhesive forces to act. But that's not the strangest part. Simply touching surfaces isn't enough to create a lasting bond. Many glues work by mechanical interlocking, where the liquid adhesive flows into tiny irregularities on the surfaces. As the glue hardens, it forms miniature hooks that physically grip the materials, locking them together tightly. Think of it like pouring liquid plastic into two rough, jagged puzzle pieces that then solidify and interlock. Other glues rely on much more powerful forces, creating chemical bonds directly between the glue molecules and the surface. These powerful covalent bonds are essentially sharing electrons, forming new, extremely stable molecular structures across the joint. Wait until you hear what comes next about the different ways glues transition from liquid to solid. Some common glues, like white school glue, simply dry, allowing water to evaporate and leaving behind a solid polymer film. This type of glue hardens as the polymer chains draw closer together, forming a strong, interconnected network. Other glues, like epoxies, undergo a chemical reaction between two separate components when mixed, creating a strong thermoset plastic. This reaction forms rigid, cross-linked polymer structures, making the bond incredibly resistant to heat and chemicals. Superglues, or cyanoacrylates, cure almost instantly by reacting with tiny amounts of water vapor present in the air. This rapid polymerization creates exceptionally strong bonds, often within seconds, making them incredibly convenient for small repairs. And then something unexpected happened with pressure-sensitive adhesives, which require no drying or chemical reaction. These sticky substances, found on tape, remain permanently tacky at room temperature, forming an instant bond upon contact. They rely on viscoelastic properties, meaning they behave like both a liquid and a solid, deforming to make contact. The choice of glue depends entirely on the materials being joined, the required strength, and environmental conditions. For example, wood glues often penetrate wood fibers, creating a bond stronger than the wood itself once cured. Conversely, industrial adhesives for aerospace must withstand extreme temperature fluctuations and intense vibrational stress. Understanding these subtle differences is key to appreciating the vast, often unseen, world of adhesive technology. Each type of glue is a marvel of chemical engineering, optimized for its specific purpose in our modern world. The impact of adhesive technology on daily life is simply immeasurable, touching nearly every industry imaginable. In construction, powerful glues often replace welds or rivets, creating lighter, stronger, and more aesthetically pleasing structures. Modern aircraft and automobiles extensively use specialized adhesives to reduce weight, improving fuel efficiency and performance. Imagine a car held together by thousands of tiny welds. Adhesives offer a smoother, more distributed stress load. Medical adhesives are revolutionizing surgery, allowing for faster wound closure, reduced scarring, and less invasive procedures. They are even used internally to seal tissues, deliver drugs, and repair delicate organs with incredible precision. Your electronics, from microchips to phone screens, rely heavily on tiny, precise adhesive bonds to function seamlessly. Without these miniature, high-performance glues, miniaturization of devices would be practically impossible to achieve. Packaging, textiles, footwear, and furniture production all depend on robust, cost-effective adhesive solutions every single day. Even in art conservation, special reversible glues are used to repair priceless artifacts without causing further damage. Adhesives and also more contribute specialized significant light bonding to agents' sustainability by enabling lighter materials and more efficient manufacturing processes. They allow for the joining of dissimilar materials that might otherwise be difficult or impossible to combine effectively.
The constant innovation in adhesive science continues to push boundaries, creating stronger, smarter, and more specialized bonding agents.
This humble substance truly underpins much of the technological advancement we experience and often take for granted. From ancient sap to advanced polymers, glue demonstrates humanity's persistent quest to connect and create. Its silent strength literally holds our complex, modern world together, often in ways we never consider. The science of adhesion is a profound example of how simple principles can yield extraordinary, world-changing results. If you found this microscopic journey into the world of glue fascinating, subscribe for more incredible stories like this. Let me know in the comments what everyday object you'd like us to explore next, and hit that like button.